Hi everyone. Today we're going to be learning about logarithms. Logarithms are a mathematical operation that is the inverse of exponentiation. In other words, logarithms tell us what exponent we need to raise a base to in order to get a certain number. Have you ever heard of logarithms? They may sound intimidating at first, but fear not. In this video, we will be mastering logarithms together, providing you with a comprehensive guide for beginners. End of this video, you will be able to 1. Discover the relation between indices and logarithms. 2. Define the logarithms of a number and the logarithms of a number from graphs and tables. 3. Using tables of logarithms and anti-logarithms to perform basic operations on numbers greater than 1. Relationship between indices and logarithms. Indices and logarithms are closely related mathematical concepts. An index is a power to which a number is raised, while a logarithm is the inverse of an index. In other words, the logarithm of a number is the power to which another number must be raised to equal the first number. For example, the index of 2 to the power of 3 is 8, because 2 raised to the power of 3 is equal to 8. The logarithm of 8 to the base 2 is 3, because 2 raised to the power of 3 is equal to 8. Next, we will delve into the various properties of logarithms. Understanding these properties is crucial as they form the foundation for solving logarithmic equations and simplifying expressions. Throughout the video, we will provide clear explanations and examples, making sure you grasp each concept before moving on. We want to ensure that you not only understand logarithms, but also feel confident using them in your own calculations. Use them in your own calculations. To further enhance your learning experience, we will solve practice problems together. Defining logarithms. Let's start by defining logarithms. The logarithm of a number n to the base b is the power to which b must be raised to equal n. This is written as the log n to base b. Let's write a complete equation for better understanding. The logarithm of n to the base b is equal to the power to which b was raised to get n. Let's assume the power was x. See how it is written. Here are some of the laws of logarithms and indices. Logarithm of power. The logarithm of a power of a number is equal to the product of the logarithm of the number and the power. For example, the logarithm of 81 to the base 3 is 4, because 3 raised to the power of 4 is equal to 81. Logarithm of a product. The logarithm of a product of two numbers is equal to the sum of the logarithms of the two numbers. For example, the log of 81 multiplied by 27 base 3 is equal to the sum log of 81 base 3 and the log of 27 base 3. Now, the logarithm of a number to a given base is the exponent to which the base must be raised to obtain that number. Log 81 base 3 is equal to 4, and log 27 base 3 is equal to 3. Therefore, the sum of the two numbers is 7. Logarithm of a quotient. The logarithm of a quotient of two numbers is equal to the difference of the logarithms of the two numbers. For example, the log of 81 divided by 27 base 3 is equal to log of 81 base 3 subtracted by log of 27 base 3, because 3 raised to the power of 4 minus 3 equal to 81 divided by 27, which can be written as log 3 base 3, and let's assume it is equal to x. Therefore, 3 raised to power x is equal to 3 raised to power 1. x equal to 1. Now method 2 of the same equation. Let's start by separating the information log 81 to base 3 is equal to x, 3 raised to power x is equal to 81, which is also equal to 3 raised to power x is equal to 3 raised to power 4. The 3 is cancelled, therefore x is equal to 4. Similarly, log 27 to base 3 is equal to x, 3 raised to power x is equal to 27, which is also equal to 3 raised to power x is equal to 3 raised to power 3. The 3 is cancelled, therefore x is equal to 3. Therefore, log 81 to base 3 minus log 27 to base 3 is equal to 4 minus 3, where 4 is gotten from log 81 to base 3 and 3 is gotten from log 27 to base 3, which is equal to 1. Let's go through some things we learned about logarithms. Study these things. If you have any problem, send a comment so we can work on them and help you improve. Throughout this tutorial, we will break down logarithms from their basic definition to their various properties and applications. We will explore how logarithms help solve exponential equations and unlock their significance in various fields such as science, engineering, and finance. Our experienced instructor will guide you step by step, providing clear explanations and real-life examples to ensure a complete understanding. Use of graph in logarithms. Graphs can be used to visualize logarithmic functions and to understand their properties. The graph of a logarithmic function is a curve that has the following characteristics. It has a vertical asymptote at x equals sine 1. This means that the function approaches infinity as x approaches 1. It increases as x increases, but at a decreasing rate. This means that the function values get larger as the x values get larger, but the rate of increase slows down as x gets larger. The shape of the graph depends on the base of the logarithm. For bases greater than 1, the graph is concave up. For bases between 0 and 1, the graph is concave down. This topic will be treated completely in my next video. Subscribe to get more information about this and more. Thank you for joining us on this journey to master logarithms. We hope you found this video helpful and informative. If you did, don't forget to give us a thumbs up and subscribe to our channel for more educational content.